Jingleheimer Schmidt, his name is my name too.
An introduction to proteins. John Jacob Believers first labeled the first protein in 1838 after the Greek word for of primary importance, porta. In 1962, James B. Sumner discovered that the urease enzyme was a protein. Before this time, it was not realized that many enzymes responsible for the chemical reactions in your body were proteins. Mark Purtuz and Sir John Cowdery Kendrew designed the first protein structure in 1958. Facts on proteins. Silk is actually protein coming from silkworms. Leather is made from the protein found in animal hide. Protein engineering is the science of using microorganisms to make proteins. Disruption of the oligomeric matrix in the college during childhood can result in dwarfism. While some people believe that large intakes of protein supplements will help make their muscle tissue increase, intakes of protein can dehydrate and result in kidney damage, weight gain, and nutritional deficiency.
The functions of proteins. About 15% of your body is made of protein. This includes much of your muscles, cartilage, skin, and hair. Antibodies and hormones are also proteins. Of all the protein used in your body, about 30% is collagen. Collagen consists of strands of tropocollagen found in groups of fibrils and microfibrils. Tropocollagen is made up of 3 left-handed helixes called polypeptide chains, which together form a right-handed superhelix. Tendons are made of strong collagen fibers. The elastin protein makes up ligaments and arteries. The elasticity of elastin helps regulate the flow of blood and hold joints together. Many different types of protein are used in your body, and combinations of proteins are used in filaments. The 6 polypeptide strands make up the myosin protein, which form thick filaments, while actin, troponin, and tropomyosin proteins form thin filaments. These filaments allow for the contraction of muscles. The keratin protein makes up your hair, skin, and nails. Bundles of protofibrils, microfibrils, and macrofibrils can be found in each. Some proteins are enzymes, which act as catalysts, regulating the speed at which chemical reactions take place. Because of this, proteins have a large effect on your metabolism. Antibodies are made up of combinations of proteins with carbohydrates. The proteolytic enzyme works as a catalyst in antibodies, dividing them into 3 parts, known as Fa, Fb, and Fc. Various senses also require proteins. In order to smell or taste objects, you need to have receptor cells. These receptor cells are made up of proteins and can be found in groups in the form of taste buds and also in the nasal cavity.
The molecular structure of proteins. Proteins, as you know, are organic compounds that contain hydrogen, nitrogen, carbon, and oxygen. They are polymers of amino acids. Proteins can be arranged into long chains joined by peptide bonds, and these are covalent bonds that join 2 amino acids. Proteins contain at least 1 polypeptide chain as well as various other chemical groups. Proteins are linear heteropolymers that are built from 20 different L-sigma alpha amino acids. All amino acids share common structural features, including an alpha carbon, to which a carboxyl group, amino group, and various side chain are chemically bonded. Proteins mainly differ in the type of side chain that they have. Side chains have varying chemical properties that largely determine the protein's 3-dimensional structure, and these are also critical to the protein's function. Some very important terms to know when discussing proteins are proteins, and these are the complete biological molecules. Peptides are short amino acids oligomers, and these often lack in a well-defined structure. Polypeptides are any single linear chain of amino acids, usually regardless of length, but often implies an absence of defined tertiary structure. There are basically 4 main types of protein structures, and these include the primary structure, which is the amino acid sequence. The secondary structure is a regularly repeating local structure that is stabilized by hydrogen bonds, and the tertiary structure is the overall shape of a single protein molecule, and this includes the spatial relationship of secondary structures to one another. Quaternary structures, lastly, is a shape or structure that results from the interaction of more than one protein molecule, and these protein molecules are commonly called protein subunits. There are many types of proteins, and proteins can be arranged into two main categories. These are fibrous and globular proteins. Fibrous proteins include cytoskeletal and extracellular matrix proteins. Various fibrous proteins are tubulin, actin, keratin, myosin, dystrophin, collagen, elastin, and reelin. Globular proteins, on the other hand, can be divided into various subcategories. These subcategories include hemophobic proteins, cell adhesion proteins, and DNA binding proteins. And some globular proteins are hemoglobin, myoglobin, neuroglobin, cytoglobin, the hemoglobin, cadherin, and integrin. Another type of a subcategory of globular proteins are chaperone proteins, and these are used to help other proteins when they are folding. Proteins can fold into unique 3D structures, and the natural fold is known as the native state.
Sources of protein. Proteins remain a component in our diet because animals cannot produce all the amino acids and must obtain essential amino acids from food. Adults need at least 1 gram for every 1 kilogram they weigh. Proteins are formed by amino acids that utilize information that is encoded in genes. Protein is abundant in many meat and dairy products. Sources of protein include milk, soy milk, eggs, tofu, yogurt, cheese, fish, beef, chicken, and nuts. There are 2 types of dietary proteins, complete proteins and incomplete proteins. Complete proteins are proteins containing all of the amino acids. Examples of complete proteins include a variety of meats. Incomplete proteins do not have all of the amino acids. Fruits, vegetables, grains, and nuts are all incomplete proteins. You've got to have the protein bar, an ice cream bar that's good for you and tastes great too. Does your teenager only eat junk food? Are you afraid they aren't getting all the nutrients they need? If so, look no further than the protein ice cream bar. Now you can give them what they want and what you know they need. So, what is the protein bar? 2 wafers rich in fiber surrounding a soy-based soft-serve product with added peanut pieces. The protein bar is low in fat and gives you the protein you need the way you want it. This energy ice cream bar has been enriched with vitamins and minerals essential to a growing teenager. A variety of amino acids have been added to the protein bar so that 100% of the amount of protein you need daily can be found in a single source. With less fat and more nutrients than any product of its kind, the choice is elemental. The protein bar provides substantial amounts of carbon, oxygen, hydrogen, and nitrogen, the 4 elements mainly found in our bodies. Visit your local grocery store today to get the protein bar for only $1. What are you waiting for?
Jacob Jingleheimer Schmidt, his name is my name too. Whenever we go out, the people always shout, John Jacob Jingleheimer Schmidt. Jacob Jingleheimer Schmidt.
See what happens when you eat the protein bar?
Whenever we go out, the people always shout, John Jacob Jingleheimer Schmidt. Jacob Jingleheimer Schmidt, his name is my name.
See what happens when you eat protein bars?
Whenever we go out, the people always shout, John Jacob Jingleheimer Schmidt. Jacob Jingleheimer Schmidt, his name is my name too. Whenever we go out, the people always shout, John Jacob Jingleheimer. Jacob Jingleheimer Schmidt, his name is my name too. Whenever we go out, the people always shout,
See what happens when you eat the protein bar?
Jingleheimer Schmidt. Jacob Jingleheimer Schmidt, his name is my name too. Whenever we go out, the people always shout, John Jacob Jingleheimer Schmidt.
See what happens when you eat a protein bar?
Jacob Jingleheimer shout.
Protein power!